Hi, this is Sam Michel, and I have the pleasure of reading this essay. It could be very important. It could be extremely important. Um, we won't know until future science sort of investigates. I won't be able to do it myself. I mean, not really. Um, when someone proposes something like GR, it's typically or what do you call it? It's more than just proposing it. When someone figures out the details of GR the way that Einstein did, it took them a number of years to validate it and authenticate it. So it may take some time. If this is at that level, if it is at that level of what do you call it? I don't like that expression, knowing the truth. What would be making accurate statements about reality. Let's put it like that. If the following essay and implied model is accurate, it will take some time to authenticate. So it may take some time. All right. So this is the essay. It's worth a shot, and it's a very concise version of something I've been working on for a number of years. Dated October 23rd, 2023. Starts out with a function. And that function is a very, very simple oscillatory function, as we will see, with a kind of decaying period. The period gets longer. So it's a very, very simple function, sine of 1 over x plus pi over 32. And if you remember from your, from your math courses, that whenever you add something to the x value, you shift it left. So you shift it left. So the original form is 1 over sine 1 over x, or sine x to the minus 1, and then adding pi plus 32 actually shifts the function left. So here's a graphical display of the function. To the right of, it's essentially I try to capture screen capture x greater than or equal to 0, and then it's going to oscillate between -1 and 1, and then as you can see, it's like not a damped sine wave. It's like what is it? Well, anyways, it's got a peak, a first peak, and then a second peak below, and a third peak. And we'll describe it, meaning, where it's a very simple, dynamical model of our early universe, attempting to explain inflation, current accelerated expansion, and elementary particle creation. The first peak could correspond to inflation, proton and electron creation. The first dip below 0 could correspond to anti-neutrino creation. And the second peak above 0 could correspond to our current accelerated expansion period. Global convexity and global concavity would correspond to excursions above 0 and below, respectively. This dynamical model is based on the system's notion of a system equilibrating with respect to global curvature. Very few global parameters would need to be specified in this framework. Proton over electron mass ratio, initial concavity. Let me go back and you'll see what I'm talking about. Initial concavity would be right there at the bottom left. Initial concavity. On the bottom would be concavity. The upper part would be convexity. So we'd be in a current in a convex. The accelerated expansion that we're experiencing right now would be a relative global convexity. So back to these global parameter specifications, at least what do you call it, broadly defining them: proton over electron mass ratio, initial concavity, C, the energy propagation rate, would include like what photon rate of propagation through empty space, and also gravitational wave propagation, same thing, same speed. Some specifications regarding global Planck scale elasticity, that's something that is recently added. So basically four parameters, not parameter ranges, just the general attributes of the four parameters that would need to be specified in this type of framework or framing of the early universe and current. It's quite possible that global expansion rate is intimately tied to global convexity, as it seems to be currently. In other words, we don't have to specify that. It's part of the model, it's part of the framing. We may be able to get away with a 4-parameter defined cosmos. The last essay was about Occam's razor. The essence of that principle: simpler is better. What the model above doesn't explain, we can modify so that it does. And if we do that over and over again repeatedly so that it explains everything that the current framework can, including what? Standard model and lambda CDM, both? If the accumulation of modifications is no better than what we have now, in other words, those two models, including GR, so in a sense, I'm trying to compete with all three models at the same time, all three frameworks. I'm trying to compete with GR plus the standard model plus lambda CDM all at the same time. If the accumulation of modifications is no better than what we have now, at least we tried to frame things in a different way. This is still good science. So what's implicit in this modeling framework is that it's trying to unify and simplify at the same time. Unify and simplify at the same time. Like I said, in a sense, it is competing with general relativity, the standard model of particle physics, and lambda CDM, which is the so-called standard cosmological model, in a sense. Dated October 23rd, 2023. It's worth a shot. It's definitely worth a shot.